Good afternoon, everyone. Welcome to Make It Happen session. We're excited to have you today. We have a really good presentation today concerning Jim Shivikalinga, and I know probably most of you, if not all of you, know Jim. So he is the inventor of the Trifocal lens technology, but he not only invented the technology, he actually uses the technology, and that's what makes this exciting. In the next 5 or so minutes, I will just talk about TLA. I'm the Senior Licensing Manager for the Optical Sciences College and at TLA. And yeah, after that, I will give Jim the floor to present and tell us about how he came up with the invention, what motivated him to do this, and how it all came about, and also a little bit about the technology and how it works. And after that, we will have questions at the end. So welcome, everyone. And I'll talk about TLA a little bit. TLA is the arm of the university that is really involved with tech transfer. What we do is we champion technologies that are invented at the University of Arizona, and we protect them and then commercialize those technologies to ensure that they have impact in the world, typically solving problems, creating jobs, and improving life. Ours is really to make the world better through technology, through innovation. And so we're always very excited about what we do. We essentially are really a professional organization that commercializes UA technologies. How do we do that? The way we do this is through a process as an organization. We start with getting inventions from the inventors and researchers and faculty, and then after getting that, we solicit invention disclosures, and we report those inventions. We do commercial assessment of the technologies, and if we find an opportunity, we protect that opportunity through patenting. And protection essentially means we file patents and the whole process of patent protection from filing an initial patent and until we actually get the patent issued. So after that, we try as much as possible in the whole process, as the process of patenting continues, we also try to get those technologies to the marketplace. And the way we do that is through 2 ways. Either we try to create teams for venture creation, or we license to established companies in the industry. In some cases, some technologies are not fully ready for commercialization. So we have an asset development program where we try to develop those technologies a little bit more before we can license those to the market. And then after we have licensed those technologies, we manage the licensees and the technologies as throughout the whole cycle of commercialization, really, until they mature and have an impact in the industry. So as you will see today, this is one of the technologies that has actually gone through the whole process. We did not we don't commercialize it through a startup, but we ended up in licensing to a major company in the industry. So essentially, our organization is really a very it's an organization that has licensing and venture creation, and also some other cross-cutting functions. So we're involved in engaging the inventors, as I said, assessing the market, protecting the technology, and marketing the technologies to startups as well as to the industry. And then also we have programs for venture creation, here, startup formation. We facilitate and coach, and we have NSF ICOPS programs as well. We manage that. And then we assist to some extent also for startup companies with getting funding where we can. but we facilitated mainly that those where necessary for venture companies to get funding. So we have a unique network where we can really engage the community, the industry, a big commercialization network, and we have mentors within TLA, people who have a lot of experience from industry to guide startup companies and also with the licensing. How are we doing? Actually, we've been doing pretty well. I mean, we look at the year FY20, the technological commercialization cycle, and what we have achieved through the amount of money that has actually come out of the research funding. And we, for example, for just that year alone, we have 260 invention disclosures. We got 87 patents issued. We had 343 patents filed. We executed exclusive 51 exclusive licenses and options, and also made some money, 7.3 million in royalties of income. So we are creating impact at TLA, and the university is progressing extremely well in this area in terms of really getting innovations into the marketplace. So finally, really, actually, just for the optical sciences college, I just wanted to show that we have actually ended up in getting a lot of startups over the years, almost 30 startups over the year, which is almost a third of the startups actually we have created in the university. So I think it's a remarkable. You can see that just only for the College of Optical Sciences, we have really done well. So we are excited about what we do, and yes, if you want to connect with us, contact TLA for optical sciences. You can contact me, and the information is there. So welcome again to this session, and you can fill in your questions through the chat, and then we can address those at the end. So I will stop here and give the opportunity to Jim to introduce himself and to talk about his accomplishments in this for this technology. Thank you so much.
Great, thank you, everybody. Let me just pop up the
you can share now. Yeah.
Window here, and let's see. Yeah, so my name is Jim Schwergerling. I'm a professor in the College of Optical Sciences. Been there since, well, I've been with the university since 1998, and with the College of Optical Sciences, my primary appointment since about 2010. And today I'm going to talk a bit about technology that we were able to develop in my lab, licensed to industry, and as you'll see, I actually became recipients of the technology as well. So you'll hear my biased opinion on how well it works. So, and excuse me, my allergies are going a little crazy, so I'm going to be sniffling a little bit through this. So, couple things, little background about the eye. So the invention is a artificial implant that's put into the eye to restore vision after cataract surgery, and I'll get into some more details here shortly. But basically, the things that you need to know is that behind the iris in your eye is a lens, and the lens is flexible. And as you constrict the muscle around this lens, it fattens up. And this is what allows you to focus far away and up close. And you can shift to any position in between. And that process is called accommodation. Now, a couple things happen as we age. When you are young, you can accommodate a lot. So you can focus on things close up to your face. And as you get older, that position gets further and further and further from your face. And so somewhere usually in your sort of mid to late 40s, you have lost the ability to easily change this focus. And that's when you start seeing people in the restaurants holding the menu far away from their face and trying to read it because they can't adjust that lens enough to focus up close. And so here's just a sort of a graph of what happens. So when you're young, you can focus about 5 centimeters from your face. So that is about 2 inches. And as you get into your 40s, this gets to about reading distance. And after your 40s, it's progressively getting further and further away, and your arm's not long enough to actually to reach that point. One of the other things that happens as you age is cataract. And cataract is basically just a clouding of the natural lens. So in the US, most of the time you see on the picture on the left here, we get this little opacification, scatters light around the eye, makes it difficult to see, reduces contrast, lots of glare at night, and that kind of stuff. And this is typically what we see in the US these days. And once you get to this point, typically you'll have surgery to fix that lens. If you let this go, ultimately it would look something like on the right here. We typically usually don't get to this point in the Western world, but there's still roughly 20 million blind people in the world that have cataracts that look like the picture on the right here. And this is completely fixable with a simple surgical intervention. So the standard of treatment for fixing cataracts is to go in and remove your natural lens lying behind the iris and replace it with an artificial lens. And these are called intraocular lenses, or IOLs. The first one was implanted in the late 1940s, and it was ridiculed by many surgeons for many, many decades until it was finally started gaining acceptance in the 1970s. And the idea was, who would want to take a perfectly good eye and put something artificial into the body? And nowadays we have all sorts of different implants that we put into the body and don't even think about it. So, but since about the 1970s, basically we come in with this biocompatible lens, and we place it in behind the iris, and it makes up for what was removed from the eye. Now, one of the problems with this type of surgery is that you are now frozen at a particular focus. And so typically they'll pick the lens to have a power so that everything is crisp at distance, but this lens doesn't move or change shape like the natural lens. And so you can't focus up close. And so you can have perfectly clear distance vision, but now you got to put on a pair of glasses in order to read. And you may even put on a different pair of glasses to work at the computer because the distances are a little different there. This is kind of the standard of care for treating cataracts these days. So removing the cloudy lens, implanting a single power lens that freezes your distance. The procedure is covered by Medicare and most insurances, so it's usually no out-of-pocket cost to the recipients. Most people are in their 60s to 80s when they have the procedure done, and it's really the clouding is due to sort of lifetime exposure of ultraviolet rays. And so just like a piece of plexiglass will yellow if you leave it out in your backyard, the same thing happens with the crystalline lens. It absorbs that UV and tends to yellow and cloud up with age. So because of this age group, most of these people are already presbyopic. They've already lost their ability to focus up close. So they may be already using reading glasses and computer glasses and that kind of stuff in order to see up close. However, as we go on here and healthcare gets better and stuff, patients these days are much more active, and they want to be able to do their activities without the need for glasses. They want to be able to, see the golf ball when they're playing golf, or sit down with a tablet and be able to peruse the news, or and that kind of stuff, and not have to fumble for the right pair of glasses for various activities. So that push in the marketplace really led to the development of bifocal IOLs. Now, bifocal IOLs they come in a variety of types, but the primary ones that are used are called diffractive lenses. And basically what this does is it takes the traditional lens, and then on one surface of that, it puts kind of a Fresnel lens, so like a lighthouse lens on the one of the surfaces of that lens. And what this does is it causes the light to split as it passes through the diffractive element, and consequently you get light going to two different foci. So we can create a lens now that effectively has two prescriptions in it, and we can set those to have one prescription for distance and one prescription for near. So here's an example. This is probably the first one that came to market. This is sort of early 2000s. It's called the Technis Multifocal. And you can kind of see on the lens here, it's a little faint, but on the right-hand side here, you can kind of see these concentric rings that are making up kind of like the lighthouse lens. It's easier to see in the eye when you have some oblique illumination. You can start to see the steps that occur between the different regions of this lens. So diffractive bifocals became widely available roughly 20 years ago now. They're not covered by most insurance plans. So if patients want them, they have to pay a premium. It's usually a couple $1,000s above what insurance covers. So insurance will still cover up to the base amount, and then the patient's responsible for whatever's left over. These lenses are great for distance and near vision, but can have some loss of contrast and some stray light artifacts, especially under night conditions. And about 10% of cataract patients opt for bifocal diffractive lenses. And so I think this is driven both by not wanting to pay for something and by just some of the artifacts or limitations to vision that they can impose. Now, of course, as soon as bifocals became widely available and people started getting them implanted, their next complaint was that now they can't see the computer screen. They can read fine, they can drive, but now they can't see their computer screen. They either have to kind of hunch in or get a special pair of computer glasses in order to see screens and tablets and that kind of stuff. So that's kind of where my invention comes in. If we do a kind of a cross section through that lighthouse lens, it kind of has these series of steps in it, and these steps are what causes the light to split into the two foci. Somewhere around 2007, I don't know exactly, I had this idea for a trifocal IOL, and the idea is actually really simple. It's basically just taking the idea that we saw before, but now alternating the heights between each step so that you have a high step and a low step. And that is sufficient to give you now 3 foci. And the idea just kind of languished. It was something like, oh, that's a good idea. You know, I should do something about it. And of course, you know, you get busy with teaching and grants and all that stuff. And I didn't really do anything with it until I was invited to a conference in early, actually, I think it was 2009, not 2010 here. And I wanted to present something to the something new and fun and that kind of stuff. And so I wrote up the disclosure for the technology and sent it to TLA, and they filed a provisional patent just before the conference. So this would have been February of 2009. I apologize for the dates here. I'm trying to remember things from long ago. So the idea here now is that, again, modulating these steps between high and low, we can now get 3 different powers or prescriptions in the same lens. So one for distance, one for your computer, and one for reading up close. And the relative heights between these steps controls how much energy is delivered to each of these. And so we can play games and we can put more in the distance or more in the near. And so it's a pretty versatile technology. And here are just some simulations of looking at a 20/20 letter E on an eye chart. The top row is just a normal single power monofocal lens. And so it provides clear vision for things that are far away, but as things get closer and closer, they very quickly blur out and you can't read. So reading is usually somewhere around 33 centimeters here. The middle row here is a lens that's probably one of the most popular bifocal technologies. And so it has clear vision for things that are far away and for things at reading distance. But you'll note that there's some loss of contrast in the letters there compared to just a conventional lens. And so what you gain in being able to see up close, you kind of lose in contrast. And then the last line here is with this new trifocal concept. And here it's distance, intermediate vision where your computer would be, and then reading distance. And you can see here again, you're losing contrast, but now you're gaining not only the near vision, but also the intermediate vision. And then, like I said, if we play games with the different heights of these steps, we can shift energy. So the top one has equal amounts of energy within the 3 different foci. And so, but we can also play games where we put more energy into distance, suggesting that distance would be sharper, have higher contrast, but you still get some benefit for intermediate and near. And then the bottom one's just the reverse of that. So kind of pushing more energy into the near focus. So I'm going to talk a little bit about the trifocal IOL players in the world and how they all relate to one another. And I'm just kind of using primates here as metaphors for the different companies that are kind of in this space right now. So the first one is Felipe. So Felipe is a very small company and is based in Belgium, and it does fairly small business and is mainly limited to European Union companies or countries. The second one, Caesar here, is a company based in Germany, and they're kind of a global powerhouse in optics and have broad range of capabilities in intraocular lenses, except for the US, but most of the rest of the world, but not the US. And then the last one here, the Kong, and Kong was based in Switzerland here. And so these are really the three companies that are duking it out right now for the trifocal market. Felipe here is got the head start on everybody. So small company, can move fast. Got a product to market in about 2011, I believe it was. And they were getting rave reviews for their lenses. And that's word of mouth and excitement caused Caesar here to say, hey, I want to get in this market here as well. So Caesar came up with their own lenses and started to market them in the EU and beyond. And Felipe got pretty mad about this and decided to sue Caesar. And it's not quite a fair fight here because of the differences in sizes and depth of funds and that kind of stuff. And so they started suing each other, and it went on for quite a while. Eventually what happened is they ended up cross-licensing their technologies. In the meantime, Kong down here is dealing with some other issues and hadn't really paid attention much to this market, but all the screeching going back and forth between Felipe and Caesar here kind of woke Kong up, and Kong said, well, I need to get into this market as well. And so Kong came in with their own technology platform. And fortunately, I've been working with Kong for over 20 years now, and we have a really good relationship. And so when they decided to pursue a trifocal lens, they were very interested in licensing the IP, and so they connected with TLA and hammered out a licensing agreement, which has really blossomed beyond my wildest dreams. So now we have this trifocal partnership between me and Kong here, and Kong is nice because it has global reach for these projects, and has really facilitated the patenting of the technology on a worldwide basis. Let's see. So Kong also put their own spin onto the technology and developed and commercialized a product called the PanOptix lens. And so it still has this lighthouse lens looking pattern on it. But again, now it has these variable steps, and they actually use 3 different steps instead of 4, which has some advantages as to where the intermediate focus is. So, and just to give you sort of a timeline on some of these things here. So we filed the provisional patent February 2009, and then filed the PCT in a year later, within the 1-year window that you have with the provisional. And in that time, sort of in the 2011 range, Felipe came out with their lens, and then about a year later, Caesar came out with their lens. And then finally, in 2015, the PanOptix lens was approved for use in the European Union. 2016, U.S. patent was finally awarded, so it took a little over 6 years between when it was filed and when it got patented in the U.S. The lens itself, FDA historically has been more strict in approving medical devices, and so the lens didn't get approved in the U.S. until late in 2019. and so the lens had already been implanted in something like 500,000 people in the European Union before it ever made it to the US. 2019, the European patent was finally awarded. So Europe's a little more strict, tough to get patents in, and so it took an extra couple of years to get the patent in EU. And you'll see a couple other comments on here. Somebody challenged the patent in Australia, and we spent probably a good year duking it out with them before abandoning that patent, just because it wasn't worth the legal costs for a relatively small market to do the thing. And then right now, currently I'm probably going to spend the next month going through a couple hundred pages of both Felipe and Caesar are trying to invalidate the patent in the European Union, and so we have to go through all that and basically show why they're wrong. So this is a long process, and it doesn't it doesn't stop. As soon as you get awarded a patent, it doesn't stop. It tends to keep going. So it's been kind of a wild ride. So now I want to talk a little bit about my personal experience. And as a kid, I was emmetropic, meaning that I had perfect vision, didn't need glasses or contacts or anything like that. As I got into grad school, I got a little bit nearsighted, but not so much that I actually had to go out and get glasses. I just kind of squinted a little bit through grad school. And then at age 47, I started to get a cataract in my right eye, and that started to cause some visual problems. And that's also about the age where presbyopia kicks in. So I have a cloudy lens starting, and I'm losing my ability to shift my focus. And so I had 4 pairs of readers, kind of stuffed everywhere so that I could always grab one. And having not worn glasses or contacts for my entire life, it was really annoying to try to adapt to using them. So here's a picture of my right eye, sort of retroilluminated. And so normally, if I had a clear lens in my eye, this pupil would be uniformly illuminated. And you can see kind of in the crystalline lens, there's these kind of bubbles and opacities and stuff like that. That's causing the light to scatter and disperse and causing visual problems. And I did some simulations for what the effects of the cataract was. And so for my left eye, it was still clear. And so as I look at, my computer and outside, everything's bright and clear. But with the right eye, I had a significant loss of contrast of things. And so that makes difficult to read, or, if you're looking at low contrast text on a piece of paper or something like that, it becomes more challenging. And it's hard to really capture the contrast here, but it's not just a contrast loss, but it's this kind of ghostly haze that appears over all the objects and stuff like that. And I did some other sort of observations of streetlights. And so with my right eye, with the cataract, I would get these big circular regions around the stoplights here, and they had a kind of a speckly pattern to them. And then even with my good eye, I had things like these flares and these little rings that would appear around these bright light sources at night. And so there's stuff going on there as well. And then looking at reading charts here, with the, if I had reading glasses on and looking at these letters, you could get down to about 20/30. 20/20 is what we consider normal with the bad eye. So things were kind of fuzzy and washed out even with good correction. Left eye was still nice and sharp, and I could easily get down to 20/20. If I took the readers off, I got some effects like doubling of the characters and loss of contrast, and so really couldn't look at stuff up close in order to and still be able to easily read them. So I decided to put my money where my mouth was and get the PanOptix lens implanted into my eyes. And so it wasn't available in the US at the time. And so in the summer of 2018, I went over to Frankfurt in Germany and had surgery with Dr. Thomas Conan, who has probably implanted more of these lenses in Europe than than anybody in the world. And so I felt very confident that he could take care of me. Here's I'm getting prepped for getting my right eye done, and here they're using a little marking tool to mark basically ink marks on my eye so they can line everything up to it. And I have what was called laser-assisted cataract surgery. So in this one, basically they couple a glass interface to the front of the eye and kind of mush down the cornea, and then they use a laser to poke a whole bunch of holes in the natural lens in the eye, and this is just kind of to soften it up so it's easier to get out. And then this is kind of a cross section through that, and so here's the front part of my eye, and then here's where they're putting all the holes in the crystalline lens, the natural lens, in order to soften it up. So cataract surgery is really kind of three phases. So the natural lens sits in an elastic bag. And so the first thing you do is you peel off the front of this bag. That's called a capsular rhexis. And that gives you access to the underlying lens. And then they use a technique called phacoemulsification. So this is a probe that has a vibrating tip, and basically it shatters or breaks apart the lens, and then it's hollow, so it has vacuum, and it sucks out little chunks of the lens, and you just kind of break apart and feed the pieces into the probe until the natural lens is completely removed. And then the last step is to inject the artificial lens into that space. And so they kind of fold up the lens like a burrito and have an inserter, and they can kind of inject it in there, and then the whole thing kind of unrolls and opens up as it's is in your eye. So how did my surgery turn out? So pretty good, I'd have to say. So thumbs up from both patient and doctor. And just a cutie comparison here. So pre-op, so before surgery, but with reading glasses, the top two are what I could achieve. And again, the eye with the cataract was kind of still fuzzy. And then post-op, I could easily read, 20/20 or below with that. So things were crystal clear, no glasses after that. 3 months post-op, I had obviously returned to the US by that time, but I saw one of my ophthalmology friends here, and we measured my eyes. And so I came out just slightly hyperopic in the left eye and perfect in the right eye. And I was seeing 20/20 at distance, and then 20/16 for computer and reading distance. And again, no, no glasses or anything needed. Some observations is that I don't perceive any sort of halo or ghosting effects when I look at just printed text, but for things like a cell phone where you have self-illuminated letters, I will see sort of a fuzzy outline surrounding the individual letters. Black letters on a white background have minimal effect, but if you reverse that, that's where you really see it's light characters on a dark background is where you really see this this halo. But it's one of those things where you just kind of ignore it, and it really hasn't affected my ability to read or do activities. In terms of the street lights, the left here are the two eyes prior to surgery, and then on the right, I still have some rings around the street lights. They're much smaller than they were with the cataract, and again, I don't really find them too annoying. I feel a lot more confident driving at night than I did before surgery, mainly because I can comfortably read street signs now, and so I don't have to kind of squint to figure out what street I'm at and then turn at the last minute. Some of the artifacts associated with this is that if I look at point sources, so lights that are far away, so tail lights that are far away, or any sort of lights that are far away, I get these two rings around each one of those sources. And so again, they're there. They're better than what was there before surgery. And under daylight, it's usually really hard to see into this stuff. As you really have to see it at night to perceive them. And this is just a little more. This another simulated image I did. So this is the Rio horse track. I like to ride my bike down here in the early mornings, and so there's these spotlights that are kind of far away on the apartment complex back here. And so what I perceive is each one of the spotlights, but I get these two sort of dim rings around them. So other observations, first week, my eyes were really dry and irritated, and it was difficult to get a good image from both eyes simultaneously. The first week I had what's called negative dysphotopsia. This is kind of a shadow, and it was in the sort of lower left of my vision that subsequently went away. And the eyes tended to flip-flop. I would get one week where one eye would be really good and the other one would be a little blurry, and then the next week they would kind of shift. And it really took a few weeks for things to stabilize, and I would say it took a good 3 months for it to really lock into its final form. And so so I would say this is not, you don't get up off the table and are suddenly seeing great. It's a healing process that has to go on with this, but the wait is worth it. Just to summarize here, the lenses are awesome. This is one of the best things I ever did. And so I can do all my activities without even thinking twice about it. So don't have to find glasses, work at the computer all day, read stuff, drive my car, and the best thing is I don't have to think about it. Another thing I should say is sort of the intermediate, and near, there's sort of this box in front of me where everything's clear. And so I don't have to hunt around and find the sweet spot where everything's sharp. It's if I put something in that box, then it's sharp. And then I just want to say, working with TLA has been absolutely great. So I'm old enough to have been here prior to TLA, and it used to be that you'd come up with a good idea and file a disclosure, and then that would get filed in the circular file, and you would never hear anything about it again. And so TLA has been very aggressive at identifying new technologies and getting them either into spin-off companies or licensing them, and it's been absolutely fabulous to work with them. Some of the things I would stress that I've learned in this process: there are smart people everywhere, and most inventions are evolutionary and not revolutionary. And so you have smart people, and they all have the same clues. They're all reading the same papers that you are. And so somebody's going to come up with this idea, and it tends the same idea seems to come up all at once from multiple groups. And so if you have a good idea, get it protected as soon as possible. And provisional is actually a very, very nice way, because it gives you kind of a 1-year window to get your full thoughts together before the patent's filed. Other things I've learned is that the more successful your idea is, the more people try to minimize it or invalidate it. And they're like, oh, that's an old idea and that kind of stuff. And I would say, just keep things in perspective. Usually these are companies, and there's lots of money involved, and they're doing business, and then it's not something personal. They're just trying to come out ahead of their competitors. And then the last thing is just be ready for the long haul. So it's 12 years and counting since all this started, and we're still fending off attempts to invalidate patents, and I think that will probably go on for another year at least. So, all right. Well, thank you. Let me do that. There are my reading glasses in the garbage. So it looks like we have a couple of questions here.
We do. Would you like me to read those, or I'm guessing
I think
I
can just go through them here. So, the first question is: would patients that have previously had LASIK qualify? Most likely. It really depends on when you had your LASIK surgery. So early LASIK. LASIK is basically when you take a laser and you resculpt the cornea, the front of your eye, to a different shape, and it changes the optics a little bit. But if you've had it more recently, the change isn't going to affect the stuff that's with the intraocular implant. Some of the early days, they use very small regions where they use the laser, and that can cause some night vision effects. And I'd be hesitant to put a lens into somebody like that. So, how big is the global market? So I think there are. So really, global is broken up into 3 segments usually, and so it's usually the US is about a third, the EU is about a third, and the rest of the world is about a third. And in the US, or in each of those, there's roughly I forget what it is, 2 million cataracts that are done per year, and you have a never-ending supply of aging people to refill that, and about 10% historically have gotten multifocal lenses. And the hope with this lens is that the artifacts are minimal and the results are really good, that 10% number can grow. You're always going to have people that are limited financially because of the extra price of these lenses, but hopefully the fear of having visual disturbances will mitigate that. Trifocals are better than the bifocals in terms of visual disturbances, and really the magic of many of these designs is trying to come up with situations where you minimize those effects. And so there are things like on the PanOptix lens, the Fresnel type looking lens doesn't go all the way to the edge of the lens. And so when your pupil is large in darkness, you're not usually reading in low light conditions. And so you don't need so much effect. And so by having just a pure refractive portion in the edge, it can mitigate some of the stray light effects that you can see. And like I said, personally, I'm more confident than doing driving at night and all that stuff. Let's see. So as a research faculty member, what is the big pull of commercialization? With so much to do, what was the kicker that made you decide to take the leap and pursue eye protection and commercialization? Well, it's, there is a ton to do, but you have good ideas, and I think that we have a lot of smart people at the university, and we have a lot of good ideas, and so the key is getting those ideas to the hands of people that can do something with that. I probably couldn't have done a startup because that would have been just too crazy. I have colleagues that do startups all the time, and they kind of thrive off of that adventure. That's for me because I have plenty of stuff to do. But like I said, putting your good ideas out there, and most likely they're not going to go anywhere. But every once in a while, something will connect, and I can't tell you how much luck is involved. So just being in the right place at the right time with the right connections, having talked to somebody at some meeting or something that can open a big door for you. And so it's been a wild ride, but definitely has been really worth it. How long do the lenses last? Is there a need to replace them down the road? So typically they should last your entire lifetime. So the material is highly biocompatible. Occasionally you can get something called posterior capsule opacification, where the surgeon has to go in and kind of poke holes in the membrane that's at the back of the lens. But that should pretty much tune you right back up to that. So so these should last the rest of my life without even thinking about it. The way you describe the process, it sounds like the way the optics are produced can be tweaked. Is it possible or reasonable for patients and their doctors to customize based on activities they want to pursue? Does this make sense commercially? So yeah, so conceivably you could tweak the performance and try to come up with the ideal distribution of light for that. I don't know if it makes sense commercially because basically it's just the number of SKUs that you'd have to make and sterilize and then get them into the doctor's hands at the proper time would probably make it commercially challenging at best. And so there are different lenses on the market and they have slightly different claims. So some doctors will try to pick one lens over another lens depending on where these foci are, and that kind of stuff. Let's see, what are the cost estimates like working with TLA?
Actually, Jim, Rocky would like to answer that one if that's okay
Oh,
with
that
you.
would be great.
So,
And actually, Jim, it'd be great to hear your perspective as well. Do you want to go first and then I can chime in?
Okay, so I think in 11 years, it's cost me, I think maybe $100 because I bought something nice for Amy Phillips, who was initially helped me out with putting all this stuff together. But beyond that, it doesn't really cost anything except for your time and participation. So.
And I couldn't have said it better. That's actually perfect, Jim. So all of the costs, the filing of the patent applications, working with attorneys, licensing, all of that is covered by TLA. We have a budget to cover all of those expenses. So it really doesn't cost you anything other than, you know, a little bit of time spent on getting the patent application correct and making sure that, you know, we can get it issued. And we have a lot of help from our patent attorneys to do that. So, you know, you don't have to get a law degree in order to participate in this process.
Yeah, I think I was pleasantly surprised with how capable the lawyers were. They, you know, they can pick up a technology even though they haven't been in, you know, working in the field necessarily. They can pick it up fairly quickly and you know, draft something that's reasonable. And you know, at the end of the day, you're the expert in the technology, and so you know you need to go through it and fine tune it. But a lot of that work can be offloaded.
Yeah, and if I could just interject for a moment, you know, some of the benefits, you know, why would we do this? Why would faculty and academics participate in something like this? You know, the thing that we hear the most from our faculty is making a difference, you know, actually seeing the results of your research result in something that can benefit people. The other side of it too is that, you know, the benefits that we maybe don't think about is it helps us to recruit better faculty to the university, you know, better graduate students. It makes this, you know, a more robust university and a place that people want to be. So it's a great, you know, outcome for the university. And that's really why Tech Launch, why we do this and why there's an office. It really enhances the reputation of not only our faculty, but also of our university, the department, the college, and ultimately benefits the public that we serve.
Great.
we are at 1 o'clock right now, but we do have a few more questions.
Yeah, I'm happy
Schwerling?
to you know, to stay on, and you know, we'll, you know, obviously if people have to go, they have to go, but we can just kind of keep plowing forward until we run out of things here. So
Great, then we'll go.
What constitutes a good idea? And then this is coming from an early optics student. So one of the issues, you know, I think when I was a graduate student is that you don't know the lay of the land very well. And so you'll have something that's a good idea, and then you do a little searching and you find out that somebody wrote a paper on that, and you know, 30 years earlier. And I think the more experience you get, you have a good idea, and then you find out somebody wrote a paper on it 5 years ago, and eventually you get to the point where you know, your ideas are cutting edge. And but I would say don't dismiss good ideas. I know that TLA in the past has had students that have worked for them, and their primary role was to search for search, you know, patent and academic literature for an idea that you disclose. And so if you have something that's a good idea and you haven't found anything, I would say just disclose it and try to decide, you know, with the help of TLA to see if it's worth pursuing or not.
I'll interject. This is Doug. I'll interject just two quick things. One is, yeah, I wouldn't even worry about thinking that you have a good idea and you should disclose it. If you just have a question and you're wondering what it would take, reach out to TLA, reach out to your licensing manager. It's part of what they're there for. It's just to discuss things with you. And then another thing, just because nobody mentioned it, but it's definitely worthwhile mentioning. There is a financial benefit to the inventors as well. The inventors actually share in the revenues that the university makes on inventions, and they take a pretty significant share of it as well. And I think Eileen's sharing some of the links right now to help illustrate that.
Okay. So the next one is what does SKU? Sorry, I was using some jargon there. That stands for stock keeping unit. And basically, whenever you make a product, a stock keeping unit is how many unique items do you have to have. And so if you had, one 20 diopter lens to implant, then you could make 100 of those 20 diopter lenses. But let's say you wanted one that's good for golfing, and one that's good for reading, and one that's good for whatever, archery or something like that. Then you have to make 100 of each one of those, and so now you have 400 lenses that you have to manage, and that kind of stuff. And usually you want to have a balance between the number of stock keeping units that you have and the diversity of things that you can provide with those. It's not a continuum. Let's see. As you continue your ophthalmic research and uncover new technologies to help people worldwide, do you think you may submit new patents and CIPs as part of the IP strategy? So we've filed, I think, 2 or 3 CIPs. So CIP is basically a follow-on patent that tries to cover additional ideas off the basic idea. And yes, we have a couple of other things in the pipeline for technologies, and hopefully they will turn into something as well. All right, and then and then Rocky said yes. So so in addition to sort of helping humanity and stuff, there's definitely royalties associated with it, and the everybody gets a piece, and I think everybody's happy. So but if you don't disclose your technology and don't get it out there, you'll get a percentage of nothing. So and the university is also much better than industry in terms of this aspect as well. So in industry, you might get a plaque or $1,000 bonus for coming up with a new patent and stuff like that. So in the university environment, you're definitely vested in the success of the product. So. All right. Did I get everything here?
I believe so.
All right.
Yeah, you did. Mm-hmm.
I did put a link in. The Market Research Student Associates are the team members that Dr. Schregeling mentioned, who will go and look and see if your idea is already out there in the world. And we are hiring for those. So if you or anybody you know is looking for a student position and are interested in the entrepreneurship or commercialization process, give Jace a call, and I will put his contact information as well. And Rocky also pointed out, inventors participate in any revenue, they receive the lion's share in terms of royalties. So if you are looking to commercialize your invention, the university isn't going to take all your profits.
All right. Well,
great. Thanks, Jim. This is a really great presentation today, and thanks a lot for your contribution to the university. I think a really tremendous contribution. Yeah.
Great, thank you. No, it was a lot of fun, and obviously, if anybody has any questions that I can answer, just feel free to reach out for me. I'm happy to discuss all this stuff.
Thanks so much, Jim. Really appreciate it.
Sure thing, Rocky.